In this video, we'll be going over decode ways. A message containing letters from A to Z can be encoded into numbers using the following mapping. So A is equal to 1 and Z is equal to 26. So this means numbers from 1 to 26 has each of an associate mapping of A to Z. So to decode and encode a message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, 1106 can be mapped into AAJF with groupings of 1, 1, 10, 6, or KJF with a grouping of 11, 10, and 6. This means we can actually decode one digit at a time, or we can decode 2 digits at a time, as we can see here. Let's go down to example. So we have our 12 here, and then there are 2 ways to decode. 12 can be decoded using 1 digit each, which is 1 and 2, which we get A and B, or we can decode using 2 digits, which we get L. Let's go over the thought process. We will be first implementing a brute force recursive approach. Then for each of the index I inside our input string, we have 2 choices. We can either decode 1 digit or decode 2 digit. We will want to find the total number of ways from both choices, or to the total number of ways to decode from both choices. Then another thing we want to make sure is when we decode 1 digit, we have to make sure the digit is within the range of 1 to 9. And then when we decode 2 digits, we have to make sure the value is within the range of 10 to 26, because our largest number is 26, which represents Z here. Let's go over the pseudocode. So we're going to implement the recursive approach, and then we ask us what parameters do we need. We'll first need I, our current index we are decoding, and also our input string, which is S, so it's the input string. And then we'd ask what's the base case. If I is out of bound, we have found one way to decode. So we can return 1. Then in each of the recursive call, we're first going to create a variable ways. Is the number of ways to decode, initially 0, and then we're going to create a variable num1, which means the number or the digit if we decode it using 1 digit. So basically finding the number if we decode 1 digit, which will be the numeric value of the character at index I. We need a numeric value because the character at index I is of type character, so we want to convert it into an integer. Now we're going to create a variable num2, which basically is the number if we decode 2 digits. Basically the number if we decode 2 digits. But before that, we have to check if I is not at the last index. This means we can decode 2 digits. So we're going to retrieve the 2 digits. We can call C and D. C and D from indices I and I plus 1, because we want to decode 2 digits, so we want to pick from the 2 indices. And then we're going to set num2 to the numeric value of C times 10 plus D. Because the digit C is in the 10th place, so we want to multiply it by 10, and then D is going to be the 1's place. So for example, if we had the 12 here, so C is equal to 1 and D is equal to 12. So we want to multiply 1 by 10, so we get 10, and then we can plus 2, and we get 12. That's how we get our second number. Then if I is at the last index, this means we cannot even decode 2 digits. We can just set it to 0. So we can set num2 to 0. It's basically a way to indicate that it's an invalid number or an invalid 2-digit number. Now with the first check, if num1 is greater than or equal to 1 and less than or equal to 9, this means it's within range of a 1-digit number. So we're going to recursively find the number of ways x from I plus 1, because we have found a way to decode the current digit, so we want to move on to the next digit. So again, I plus 1, and then we increment ways by x. Now the next one is if num2 is within the range of 10 to 26, this means it's a valid 2-digit number. We're going to recursively find the number of ways from I plus 2. We need I plus 2 because we are using 2 digits, so we want to jump to I plus 2 because we're using the current digit and the next digit already. So we can set I to I plus 2, and then we increment ways by y. Then we can return ways. Let's go over the time and space complexity. So the time complexity is of 2 to the n, where n is the length of the input string. This is because each recursive call has 2 choices with a depth of n. Because when our index I is out of bound, we have found one valid decoding, one way to decode. And then our space complexity is also O of n. It's our recursive call stack memory. Let's go over the code. So we'll implement the recursive approach, keeping track of current index that we're trying to decode in the input string. Now we'll go over the base case. If I is greater than s, if I is out of bound, then we have found one possible way to decode, so we return 1. So we'll create a variable ways initially equal to 0, and then we'll first find the number if we decode 1 digit. So we can get character.get numeric value of the character at the current character at index I, and then we'll check, and then we'll find num2, the number if we decode 2 characters. So we'll first check if I is out of bound. So if I is not at the last index. If I is not at the last index, this means we can decode 2 characters. So the current character times 10 plus the current character at converting the next character at I plus 1 to a number. If we are at the last index, this means we'll default it to a valid value of 0. So we can just set 0 here. Now we have to check if the number 1 is within our range. So if num1 is greater than or equal to 1 and num1 is less than or equal to 9, then it's a valid number. So we're going to recursively find the number of ways if we decode 1 digit. And then we're going to check if our num2 is within the range of 10 to 26. If it is, we'll find the number of ways of decoding 2 digits. And then we can return ways. Okay, it's giving us a TOE error. So let's write this down. So this approach is not efficient enough and will result in TOE error. So in the next video, we will be implementing a memorization approach where we will optimize the recursive approach by caching previously calculated results in the next video. Let me know if you have any questions in the comment section below.